Our solar system, it feels like it's been here forever, right? A permanent fixture in the universe, just this stable, predictable, cosmic clockwork. But that permanence, it's really just an illusion. Today we're going to dive into the incredible, pretty violent, and ultimately silent story of how our cosmic home will one day, inevitably, come to an end.
So, is this home of ours actually eternal? Well, the simple, and maybe a little unsettling answer is no, not at all. The end of our solar system is already written in the laws of physics, and let me tell you, it's one of the most epic stories the cosmos has to offer.
For 4.6 billion years, our solar system has been this amazing, remarkably stable cradle for life. But on a cosmic timescale, that's just a fleeting moment. To really get a grip on its end, we have to start where it all begins, at the very heart of our system.
So welcome to Act 1, the Inferno. The final drama, it all kicks off with the engine of our entire system, the Sun. And its death, it's not going to be some quiet fading away. No, it's going to be a spectacular inferno, one that will completely rewrite the rules of the solar system as we know it.
And, the end for life here on Earth, it actually starts a lot sooner than you might think. In just about 1 billion years, the sun will get bright enough to literally boil our oceans away. Fast forward to 5 billion years from now, and it'll start running out of its main fuel, hydrogen, and begin to swell up into a red giant. And at its peak, maybe 7 or 8 billion years from today, it's going to have completely swallowed Mercury, Venus, and, very likely Earth itself. The sheer scale of this change is, it's just staggering. Just look at this. On one side, you've got our sun today, a nice, stable, middle-aged star. And on the other? That's its future, a bloated, unstable red giant, hundreds of times bigger, with its outer edge potentially stretching all the way out to where Earth is orbiting right now.
But, out of all that destruction comes this moment of kind of strange beauty. As the red giant pulsates and breathes its last, it'll cast off its outer layers into space. And what that creates is a spectacular planetary nebula. Think of it like the sun's final signature on the cosmos, this glowing shell of gas, a piece of celestial art that'll shine for tens of thousands of years before it finally fades away.
Okay, so the fire is gone. The nebula has dissipated into space. What's left? Well, that brings us to Act 2, the aftermath. We're looking at a quiet, maybe even haunting, ghost of the solar system we once knew.
Right at the center of this new ghost system is something called a white dwarf. It's basically the sun's super dense core that's been left behind. Try to picture this. Half the sun's entire mass crushed down into something the size of Earth. It's unbelievably dense, incredibly hot, but with no fuel left to burn, it's really just a fading stellar ghost, a dying ember. Now, this is a really crucial point. During that whole red giant phase, the sun sheds almost half of its mass, and this is the single most important change for what happens next. Why? Because when the mass of the star at the center drops, so does its gravitational pull on everything else in the system.
So what does that actually mean? Well, with only half the mass, the white dwarf's gravitational grip is way weaker. The surviving outer planets, Jupiter, Saturn, and the rest, they won't just fly off into space. Instead, they'll drift into much wider, much slower orbits. Jupiter, for instance, will probably settle into a new path that's about twice as far from the center as it is today. The whole solar system just becomes bigger, colder, and a whole lot darker.
But even this ghost system isn't the final story. It's not permanent. Now we enter Act 3, the long fade. This is a process that unfolds on timescales that are just almost beyond our ability to imagine, as the very last remnants of our solar system quietly, slowly unravel.
So how does a whole system just dissolve? Well, here's how it happens. Step 1. Remember that weakened gravity? The white dwarf's grip is pretty loose. That makes the surviving planets really vulnerable to Step 2, stellar flybys. See, over billions and billions of years, other stars will just happen to pass relatively close by. And each time one does, it gives a little gravitational tug on those planets. Eventually, after enough of these repeated little nudges, they're enough to do the inevitable and eject the planets one by one from the system for good.
Just try to wrap your head around this timescale. For the next 30 to 50 billion years.
Most of those surviving planets will be kicked out one by one. They'll become what we call rogue worlds, just cold, lonely planets wandering aimlessly through the darkness of the galaxy.
And then, by about 100 billion years from now, a stretch of time that's almost impossible to comprehend.
Our best simulations show that even the very last planet will likely be stripped away. And at that moment, the solar system, as a family of objects bound together by gravity, it officially ceases to exist. It's over. All that's left is a cold, dark, white dwarf, all alone in the void.
Okay, that's a pretty grand and maybe a little grim, distant story. So, why does any of this matter to us right now? I mean, what can we possibly take away from knowing about the end of everything we know?
Well, understanding this ultimate fate, it doesn't have to be depressing. In fact, it does the opposite. It gives us perspective. It highlights just how incredibly precious and rare our current moment of stability really is. It kind of inspires us to appreciate the here and now, to explore our universe while we still have this amazing cosmic home.
So, if we know that the story of our world has a final chapter, it really puts our own story into perspective, doesn't it? It forces us to ask a really fundamental question. Since this is our time, our fleeting moment, what will we write in the chapter that belongs to us?